Attention, attention! Something very exciting is going on Saturn. It's called a spoke season, and no, the planet isn't turning into a giant gaseous wheel. Let me tell you more about this phenomenon. Each year, NASA's Hubble Space Telescope devotes some of its time to observing Saturn, a gas giant, like me, the second largest planet in the solar system. And this space body always has something new to surprise us with. For example, look at one of the latest images of the gas giant. See those smudgy spokes? They mean that Saturn's spoke season is starting. Like our planet, Saturn is tilted on its axis. That's why it has 4 seasons. But since the orbit of the gas giant is much larger, each of these seasons lasts about 7 Earth years. Keep this in mind, it's important. Now, the next thing we need to talk about to understand the concept of the unique spoke season on Saturn is the equinox. On Earth, it's the moment when the sun is exactly above the equator of the planet, and day and night are of the same length. But on Saturn, it's something a bit different. An equinox occurs when Saturn's rings are tilted edge-on to the sun. And even though equinoxes on Saturn happen every spring and fall, just like on our planet, they actually occur very seldom, roughly once in 15 Earth years. That's why astronomers are so excited about this event. Now look, there are 2 smudgy spokes in this ring. It's called Ring B on the left of the picture. They resemble the spokes on a bicycle. The shading and shape of spokes vary. They may seem dark or light, it depends on the angle and illumination. Sometimes they might look like blobs instead of something with a classical radial spoke shape. They also don't last long, but more and more will start to appear the closer we're to May 6, 2025. That's when the autumnal equinox on Saturn will occur. But what causes the spokes? Astronomers think it might be the gas giant's magnetic field. When a planetary magnetic field interacts with the solar wind, it creates an electrically charged environment. On Earth, this results in northern lights, also called aurora borealis. And if we speak about Saturn, the tiniest icy ring particles might get charged too. And it probably temporarily levitates these particles above the larger boulders the rings consist of. For the first time, the spokes in Saturn's rings were spotted by NASA's Voyager mission. It happened in the early 1980s. At the time, we didn't know that these spokes were a seasonal phenomenon. Voyager 2 just passed by the planet and then sped on. To figure out what these spokes were and how they functioned, astronomers needed a space telescope that could observe Saturn's rings from afar, like Hubble. The latest equinox on Saturn occurred in 2009. At that time, NASA's Cassini space probe was traveling around the gas giant. It sent many amazing images back to Earth. They quickly proved that the spokes weren't caused by gravitational interactions with Saturn or the influence of the gas giant's moons or small moonlets, which make up the planet's rings. It was the year 2005 when Cassini confirmed that the spokes were related to Saturn's magnetic field. That mission was finished in 2017. Now Hubble keeps its long-term monitoring of the changes on and around Saturn. Despite all the observations, astronomers still can't predict the beginning and duration of the spoke season. Luckily, Saturn's prominent rings are a perfect laboratory for studying this phenomenon. Because even though other gas giants in the solar system also have rings, those are not so visible, and scientists don't know whether spokes occur on those planets. But these spokes aren't the only exciting space phenomenon. Our solar system is a fascinating place, that's why. If you were standing at the Martian equator barefoot, your feet wouldn't get cold. The temperature there would feel like on a sunny spring day on Earth. But you'd have to wear a hat. At the height of your head, it would be freezing cold. Now Venus spins backward compared to most other planets in the solar system and the Sun itself. One of the explanations astronomers have come up with is a collision with some solid object, for example an asteroid, that happened in the past. Jupiter's moon Io has hundreds of volcanoes, which makes the satellite the most volcanically active object in the solar system. The moon also has a weird yellowish surface. It looks blotted and resembles a pepperoni pizza. Yum. Europa, one of Jupiter's 4 biggest moons, is covered in ice. This ice shell can be 10 to 15 miles thick. It also has some smooth patches, so if you're into ice skating, you would like it there. If you lump together all the known asteroids in the solar system, their total weight would still be smaller than 10% of the mass of our Moon. Scientists believe that Mercury might still have a partially molten core. It could explain why Mercury has a magnetic field, even if it's just 1% as strong as Earth's. Mercury's core takes up around 42% of the planet's volume. Mercury also has wrinkles. When its iron core was cooling, the planet's crust contracted. It made the surface of the planet uneven. These wrinkles are called lobate scarps. The biggest of these scarps can be hundreds of miles long and up to a mile high. Uranus is the only planet in the solar system to rotate on its side. The reason might be an ancient mega-powerful collision with an Earth-sized object, but so far it's just a theory. Mars might get a set of rings of its own in the next 70 million years. Its largest moon, called Phobos, is orbiting closer and closer to the planet. One day, it's likely to get broken apart by the gravitational pull of the red planet and turn into a ring that can last for millions of years. I won't be around then, so I'll just take their word for it. Scientists think that the moon's surface has more craters than Earth's because it doesn't have so much natural activity going on. Winds, rains, earthquakes, and erosion keep altering the surface of our planet, but the moon has almost no weather to change its appearance. Saturn is the most flattened planet in the solar system. It's squished at the poles, and any point on the equator is about 4,000 miles farther from the center of the planet than the poles. The Hubble Space Telescope weighs almost as much as 2 male African elephants and is as long as a big school bus. Yeah, that's a launch I'd love to see. 2 elephants in a school bus. It's made almost 1.5 million observations since it was launched in 1990. Astronomers have used this data to write about 15,000 scientific papers. Everything on Earth and everything people can see in space with the help of telescopes is normal matter. It's made up of atoms and molecules and adds up to less than 5% of the universe. Almost 68% of the universe is dark energy, and the remaining 27% is dark matter. Does that really matter? As a matter of fact, it does. Saturn has a mysterious vortex swirling over the planet's south pole. The whole thing resembles an enormous hurricane-like storm, measuring almost 5,000 miles across. That's 2/3 the diameter of Earth. What confuses astronomers is that although the phenomenon looks like a hurricane, it doesn't behave like one. Saturn is also the only planet in the solar system that's less dense than water. In other words, if you found a bathtub huge enough to fit this gas giant, it would float there like a rubber duck. Earthquakes on the moon don't occur as often as on our planet, but when they do, it happens closer to the center of the satellite. Scientists think moonquakes might be caused by the gravity of Earth and the Sun. One of Saturn's moons, Iapetus, has bizarre two-tone coloring. The difference between the moon's two hemispheres is great. One of them is light and the other is eerily dark. Scientists haven't figured out this mystery yet. Now, the only asteroid belt in the solar system astronauts know about is between Mars and Jupiter. There are thousands of asteroids in this area. They're irregularly shaped solid objects of different sizes, but all of them are way smaller than a planet. Scientists have analyzed the chemical content of some meteorites found in the Sahara Desert, Antarctica, and other places. Some of the rocks turned out to have a Martian origin. Others arrived from the Moon or the asteroid belt between Mars and Jupiter. Ooh, space rocks. So we can also say, space rocks. Yeah, we could say that.
Do you recognize this majestic world? The second largest planet from the Sun? Check. A gas giant with a hazy yellow-brown appearance? Check. 7 huge, intimidating rings? Check. You're right, it can't be anything else but Saturn. And recently, the Hubble Space Telescope has made an astonishing discovery. Apparently, the planet's rings have been doing something to the planet for a long time. A new study has revealed that these iconic rings are heating Saturn's upper atmosphere. The coolest thing, though, is that researchers from NASA claim that it's something scientists have never observed anywhere else in our solar system. This secret has been hiding in plain view for 40 years. And only after using the observations of the planet received from the Hubble Space Telescope and retired Cassini probe and Voyager 1 and 2 spacecraft did astronomers figure it out. This unexpected interaction of the gas giant with its rings could become a tool for predicting if planets in other star systems have magnificent Saturn-like ring systems as well. So, how did it become clear that the gas planet is being slowly cooked by its own rings? The telltale evidence is an excess amount of ultraviolet radiation. It can be seen as a spectral line of hot hydrogen in the atmosphere of the gas giant. There's a bump in radiation that can only mean that something is heating the upper atmosphere from the outside. It's still kinda unclear how this process is happening, but the most probable explanation is that icy ring particles rain down on Saturn and cause this heating. But it might also be the impact of tiny meteorites or the particles of solar wind. The heating could be caused by solar ultraviolet radiation or some electromagnetic forces that pick up electrically charged dust. When NASA's Cassini probe finished its mission and plunged into Saturn's atmosphere, it had enough time to measure the atmospheric components. And it turned out that many particles were indeed falling from its rings. But in any case, the heating process happens under the influence of the gravitational field of the gas giant. You see, astronomers do know about the slow disintegration of Saturn's rings, but figuring out how this process affects the planet, that's new. Now, do you remember NASA's Cassini spacecraft I mentioned before? For more than a decade, it was studying Saturn, sharing images of the gas giant and its icy moons. It took us to marvelous worlds where methane rivers ran into methane seas, and jets of gas and ice were blasting material into space. Anyway, that very Cassini also studied Saturn's magnetosphere. The thing is, forces acting deep inside the planet produce a ginormous magnetic bubble under the planet. And this bubble is called the magnetosphere. Unfortunately, astronomers still have very little information about this phenomenon on Saturn, since magnetic fields are invisible and are, of course, best studied from within. Imagine this: million-mile-per-hour flows of electrically charged particles from the sun, aka solar wind, are spreading through the solar system. Suddenly, something appears in their way. Oh, it's Saturn's magnetic field. It protects the planet, making solar particles back away. As a result, the sun's magnetic forces are raging outside Saturn's magnetosphere, while inside the gas giant's protective bubble, its own magnetic forces dominate. Our home planet also has a magnetic field, but it creates a much smaller magnetosphere. And still, it effectively protects us from the harmful particles coming from the sun and from space. But even though Saturn is protected by its magnetosphere, the sun still manages to mess with the planet. Energetic winds from our star sweep over the gas giant, causing massive auroras. But unlike auroras here, on Earth, Saturn's auroras can only be seen in ultraviolet light. In other words, they're invisible from Earth's surface. You can only see them if you travel to space. But apparently, there are different kinds of auroras on the gas giant. For example, one more type is triggered by the charged particles coming from volcanic eruptions on the planet's moons. And some of Saturn's auroras might be caused by powerful winds swirling in the planet's own atmosphere. These winds blow in the ionosphere, which is a region located beneath the magnetosphere. The same winds might be responsible for the variable rotation rate of the planet. This phenomenon makes it difficult for scientists to figure out how long one day on the ringed planet lasts. Speaking of winds, Saturn has a mysterious vortex swirling over the planet's south pole. The whole thing resembles an enormous hurricane-like storm on Earth, but its eye alone measures almost 2,500 miles across. For comparison, the eye of a typical terrestrial hurricane is a mere 2 to 3 miles wide. What confuses astronomers is that although the phenomenon looks like a hurricane, it doesn't behave like one. It's stationary and keeps spinning over the same area of the South Pole. And while polar vortices on Earth have cold cores, the one on Saturn is warm. And now, brace yourself for another surprise Saturn has prepared for us. In an image sent to Earth by the Hubble Space Telescope, one can notice a couple of dark, shadowy spots on the left side of the planet's rings. Those are informally called spokes, maybe because they resemble spokes on a bicycle. The shading and shape of spokes vary. They may seem dark or light, it depends on the angle and illumination. Sometimes they may even look like blobs rather than something with a classical radial spoke shape. They also don't last long. But the good news is more and more will start to appear the closer we are to May 6, 2025. That's when the autumnal equinox on Saturn will occur. Now, on Earth, that's the moment when the Sun is exactly above the equator of the planet, and day and night are of the same length. But on Earth, it's something a bit different. Like our planet, Saturn is tilted on its axis. That's why it has 4 seasons. But since the orbit of the gas giant is much larger, each of these seasons lasts about 7 Earth years. An equinox occurs when Saturn's rings are tilted edge-on to the Sun. But what causes the spokes? Astronomers think it might be the gas giant's magnetic field. When a planetary magnetic field interacts with the solar wind, it creates an electrically charged environment. As we already know, on Earth, this results in northern lights, also called aurora borealis. And if we speak about Saturn, the tiniest icy ring particles might get charged too. And it probably temporarily levitates these particles above the larger boulders in the rings. For the first time, the spokes in Saturn's rings were spotted by NASA's Voyager mission. It happened in the early 1980s. At that time, we didn't know that these spokes were a seasonal phenomenon. Voyager 2 just passed by the planet after all, and then sped on. To figure out what these spokes were and how they functioned, astronomers needed a space telescope that could observe Saturn's rings from afar, like Hubble. The latest equinox on Saturn occurred in 2009. That's when the Cassini space probe was traveling around the gas giant. It sent many amazing images back to Earth. It managed to prove quite quickly that the spokes weren't caused by gravitational interactions with Saturn or the influence of the gas giant's moons or small moonlets, which make up the planet's rings. It was the year 2005 when Cassini confirmed that the spokes were related to Saturn's magnetic field. And even though that mission was finished in 2017, now Hubble keeps its long-term monitoring of the changes on and around Saturn. Despite all the observations, astronomers still can't predict the beginning and duration of the spoke season. Luckily, Saturn's prominent rings are a perfect laboratory for studying this phenomenon, because even though other gas giants in the solar system also have rings, those are not so visible. And scientists don't know whether spokes occur on those planets.
Saturn is not the only planet with rings. Neptune, Uranus, and Jupiter have them too. Check this out. Even though Neptune is so far, we still got the clearest view of its rings over the past 30 years. And check out good old Uranus. It comes with 2 sets of rings. The inner system consists of 9 rings that are mostly dark gray and pretty narrow. There are 2 outer rings. The outermost one is blue, like one of Saturn's rings, while the innermost one is reddish, just like some dusty rings you'd find in other spots in our solar system. Jupiter's not bad either. Its rings are made up of small dust particles and are so faint that we can only see them when they get lit by the sun or when we observe them directly in infrared light. There's an interesting story about how Jupiter got its rings. The dust the rings consist of formed when micrometeors, which are tiny pieces of rock and debris, hit the small moons around Jupiter. As expected, these impacts made a mess and threw up dust into space. Jupiter obviously saw its chance to get itself some nice rings, so it captured dust into its orbit. These particles of dust are really small because if the impacts were any bigger, gravity would pull the larger pieces back down to the surface of the moons. And these micrometeors keep hitting the moons and add more dust to these rings, so they always keep fresh and a bit new. Okay, cool story. But none of these planets have spectacular rings like Saturn. They're made up of small particles of ice, rock, and dust. And these pieces probably came from asteroids, comets, or moons that broke apart before they even got to Saturn because of its strong gravity. What makes Saturn's rings so special is that they're made of many tiny particles that reflect a lot of light. This is why they're visible, even with an average telescope that amateur astronomers use. When we look through the telescope, we can see the rings clearly because they're big and bright. And these chunks in the rings range in size from tiny dust grains to those as large as a house. And if we could look at those rings, we'd see some of the particles as big as entire mountains. Wow! Imagine if you could sit at the top of it and enjoy the roller coaster ride around Saturn. If you could look at the rings from the cloud tops of Saturn, they would mostly appear white. Plus, each of its rings moves at its own speed. Wow, stunning, right? But the news up there is not so good. It seems that these fascinating rings are disappearing. In fact, ever since the 1980s, astronomers have known these rings are getting smaller as time goes by. It appears that the particles from the rings are actually raining down onto Saturn's atmosphere. Not just raining. Every day, an amount of water you'd find in an Olympic-sized swimming pool falls onto Saturn. But scientists are still not quite sure how quickly these rings are disappearing and when they will be completely gone. And to see this, we have NASA's James Webb Space Telescope, JWST, and the Keck Observatory in Hawaii that will study Saturn over a long period of time. They will track what exactly happens with this ring rain and how it changes during one full season on Saturn. That's about 7 Earth years. And a lot of ring material is falling onto Saturn all the time. Somewhere between 880 and 6,000 pounds of icy rain flows onto the gas giant every second. And by this, it's heating up its upper atmosphere. If this keeps happening at the same rate, Saturn's rings might disappear in about 300 million years. Hope humankind will get at least one roller coaster ride before they're gone, though. But while this may seem long to us, in terms of space, it's relatively quick. But this rate could slow down through time, so the rings might be there for more than 1 billion years. Or, if they start disappearing faster, about 100 million years. It's not like this process happens by itself. Space rocks and the radiation coming from our sun affect all those particles in the rings. They give the particles an electrical charge. This charge causes them to stick to Saturn's magnetic field lines. Saturn's mighty gravity then pulls these icy particles in, and they flow into its upper atmosphere. Saturn goes around the Sun once every 29.5 years. As it's making its circle, it moves closer to and farther away from the Sun, and its rings do the same. This tilt affects how much the Sun's radiation affects the deepest layers of the planet's rings, which is where most of the icy rain comes from. Scientists think that when the rings are tilted to face the Sun, there will be more material falling onto Saturn. But when the rings are edge-on with the Sun, the material falling onto Saturn slows down. Scientists are not only trying to predict the fate of Saturn's rings, but they also still debate when and how they even formed. Some theories say the rings have been around ever since our solar system formed billions of years ago. But the Cassini spacecraft explored Saturn and brought some data that encouraged the idea that the rings are way younger than that, maybe 10 million to 100 million years old. Another interesting idea says the heavy rain from the rings might make them look younger than they actually are. Whoa, did those rings find their own fountain of youth? But I'm afraid not even that can make the rings last forever. Sooner or later, Saturn will have to face an identity crisis when it loses its beautiful rings. At some point, it seemed this year wasn't so good for Saturn because another one of the planets was quickly heading to take the title of the one with the largest number of satellites. In February of 2023, scientists discovered 12 new Jupiter moons. and Jupiter overtook Saturn to become the leader in the number of moons. These moons accidentally popped out while they were looking for Planet 9. You know, that one hypothetical planet that could be lurking somewhere in the outer region of our solar system. And these newly found moons are kinda dim and small, but they couldn't hide from our powerful telescope and the advanced techniques scientists used to spot them. What's interesting is that 9 of the new moons orbit Jupiter in the opposite direction of its rotation, while the other 3 orbit in the same direction. What happened to those fellas? Do they even know they got into the wrong lane? Some say they could be the remains of bigger bodies that broke apart after hitting some other objects. So typical for space. Now, there's a moon called Valetudo that was discovered a few years ago. Unlike the retrograde moons, Valetudo has a prograde orbit, which means it orbits in the same direction as Jupiter's rotation. What's interesting is that Valetudo moves in an orbit that crosses into the paths of these retrograde moons. Could it be the retrograde moons formed because they collided with prograde moons such as Valetudo at some point? Hopefully, we'll find out. It was a great success for Jupiter, but 3 months later, things changed when they also found 62 satellites circling around Saturn, which means Saturn became the leader again, with 145 moons in total, compared to only 95 of Jupiter's moons. Astronomers have discovered new moons around Saturn using a technique called shift and stack. This means they combined multiple images that shift along with the moon's movement, and this helps to enhance the faint signal from the moon. That's how they discovered even those smaller and dimmer moons they couldn't have previously seen in single images, like those that are 1.6 miles in diameter. They needed to confirm these objects were moons and not some asteroids passing by, so they tracked them for a couple of years to see their orbits around Saturn. So, Saturn may be losing its rings, but there are more moons over there than expected. And who knows how many more interesting things we'll find around it.
This is Neptune. The next stop is Pluto. Stand clear of the closing doors, please.
One day, with top-notch future technologies, one stop from Neptune to Pluto won't seem much further than Times Square from Bryant Park today. There are huge ice mountains on Pluto, valleys that go further than your eyes can see, 160-mile large craters, almost as big as the largest one on Earth, and no life. The reasons are obvious. The long distance between Pluto and the Sun guarantees freezing temperatures on that dwarf planet. It also ensures a trip of a few billion miles. Plus, it's smaller than the Moon, so it would get crowded very soon if people started dwelling there. Still, there's one reason which makes life there not that far-fetched. The Sun has a lifespan and cycles within it. Our solar system used to be nothing but a cloud of gas and dust. As a result of a gravitational collapse at the center of this cloud, the gas and dust started gathering in specific, denser places. These pulled more and more matter as time went on, and something called conservation momentum made the mass start rotating and heating up because of immense pressure. Later, there appeared a disk similar to what Saturn has, but it was made of entirely different substances. And right in the center, there was the ball that eventually became the Sun. A protostar is a young star that's still gathering its mass, and that's exactly what the Sun was before the temperatures and pressures inside of it lighted up its core. Millions of years later, it became the Sun we see every day. But it won't stay this way forever. It will heat up even more and eventually get bigger and denser, turning into a red giant. It may one day get big enough to swallow up Venus and Mercury. Chances are, it might swallow even planet Earth. Even if it doesn't devour our planet, the Sun might get close enough to touch us. Well, if this happened, life on Earth wouldn't be possible. But then, in just a few minutes, the Sun loses about 40% of its mass and shrinks about 10 times what it used to be. It's not as bright, and indeed, not as hot as it used to be. By this moment, Earth will have already been deserted. People might want to start traveling around space, or settle down on another planet where life is sustainable, like the exoplanet Kepler-62f, which, by the way, is even bigger than Earth. While all of this was happening, Pluto was changing. Before, every resource was frozen inside of the dwarf planet. Water, gases like methane, carbon monoxide, you name it. But as the sun was reaching its peak luminosity, Pluto was slowly warming up and losing a lot of what it had to the vastness of space. At the same time, an atmosphere formed up. If the atmosphere gets thick enough, it would create favorable life conditions. Then, instead of spaceships, a tiny percentage of us would be able to set up colonies on the dwarf planet. The temperature is comfortable there, almost t-shirt weather. It even resembles Earth a tiny bit. Canyons filled with water, beautiful endless fields with trees, and lots of space to run around, and mineral water pockets on the ground, good enough to drink. Pluto's rotations are different than Earth's. An Earth day is 24 hours, and sometimes it still feels like it never ends. But on Pluto, a whole rotation around the sun takes 153 hours, because it's pretty far away from the sun. After several hours without sleep, we get tired and our eyes get red. It means we'd have to take several naps throughout the day on Pluto. A year on Pluto equals 248 Earth years. Unless we come up with some sort of technology to get us to live that long, our entire lifespan would be less than half a year on the dwarf planet. So, houses on Pluto might need to be equipped with cryo chambers. Whenever you feel like dreaming for a long time, you jump in it and wake up 50 Pluto days later. On the dwarf planet, there are also seas and beaches, so it's just like a tiny Earth, far away from the actual Earth. The food on Pluto could be tastier. We might find a way to make the ingredients more savory and even try to grow them faster during the trip. You plant a carrot, and 2 days later, it's ready to be in your salad. There could also be new ingredients for our salads on Pluto. Maybe 2-meter-tall mushrooms we've never seen before. The animals we would take with us on the trip would get released into their new home forever. And with time, they would evolve and adapt to their new environments. The law of the jungle could change a bit too. Lions might not be kings anymore. Deer are. Their antlers are twice the size of what they used to be. But to be fair, so are the deer. Most of the animals that were already here used to live underwater. But with time, the amphibians started shifting to the surface, just like Earth at the beginning of life. Pluto could only be a temporary home though. Once the sun has finally reached its final phase, Pluto would get frozen and lifeless again. People instead would need to try to find a planet that stays in the Goldilocks zone of another galaxy. The Goldilocks zone is the exact proper distance from the star like the sun, where the temperature is perfect for the water to stay liquid. It's the rule scientists search for when looking for other planets that can sustain life. We can try setting new colonies on one such planet, or even try to set up our own artificial home, not exactly a planet or a spaceship, but a combination of both. Something huge built right in space, say a wheel with gravity everywhere we go, so we don't fall off. It would float in space toward the new exoplanet, capable of fitting entire states in. This whole trip might happen just because the sun first grew too much, and then, having reached the culmination of its life cycle, it would finally become a white dwarf. It's going to be a pretty long journey, and entire generations will be born here. You'll have a choice: sleep your way through the journey until humans finally reach their new exoplanet, or enjoy the trip in this fantastic spaceship. There's all you need on board: malls bigger than those on Earth, large futuristic cities, even places to farm, fields with rich soil made artificially, and finally, after a long journey, the exoplanet. It's even somewhat better than Earth. The planet is giant and has more continents. The continent's center isn't as far from oceans, which means there aren't as many desert areas. Though the sun of this planet is an orange dwarf, it's not as hot as our yellow dwarf sun today. It's a bit smaller, but here's the kick: orange dwarfs live somewhat longer. They remain stable for between 15 billion and 45 billion years. Despite that, this new planet is full of rainforests because the planet itself is warmer. It means more biodiversity and creatures we've never seen before. But even if nothing out there is suitable, we could try and terraform this planet instead. If we take Mars as an example, we could create a greenhouse effect by smashing ice-rich comets and releasing ammonia in them, making the planet warmer. We could also start planting trees. We'd probably need some Earth soil to do that, or we'd have to modify Mars's soil to be similar to ours. Sooner rather than later, the atmosphere would be close to the one we have on Earth. We'd be able to breathe too, because of the trees. Then, we can melt Mars's polar ice caps and voila, water. The problem is the solar winds and sun explosions that might strip it of an atmosphere just as quickly as we can create one, if not faster. It has no magnetosphere either, which means it can't protect us from radiation, so long-term Mars wouldn't be a good choice. Maybe out there, in the vastness that is space, there is a perfect planet waiting for us.
Consider now
Enceladus.
Saturn's icy moon, one of the most promising places to look for life outside Earth. Scientists have just detected the last one of the 6 necessary ingredients for its formation, phosphorus. This rarest element has been discovered in an ocean on Enceladus. This rare element helps make the soil fertile on Earth. But the concentration of this mineral in the hidden seas on the distant moon might be from 100 to 1,000 times greater than in the oceans of our home planet. It might be because
Enceladus.
ocean is rich in carbonates, just like soda water, and this soda water is likely to dissolve the phosphates in the moon's rocks. The new discovery also suggests that on other icy moons of Saturn, like Titan, the waters may be loaded with phosphorus too. Why are scientists so excited about this mineral? Well, phosphates, which are compounds that contain phosphorus, are crucial components of life on Earth. DNA, RNA, and cell membranes contain them. But among those 6 elements required for life, which are carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, phosphorus is the least common. In 2004, the Cassini space probe entered the dust from the second outermost ring of Saturn, called the E-ring. It's made up of ice grains Enceladus ejects. And while studying these ice grains examined by Cassini's cosmic dust analyzer, researchers have detected phosphorus.
Enceladus.
Is the 6th largest moon of Saturn. It's not really large, only 314 miles across. This makes the space body small enough to fit inside Arizona. We should try that sometime. Interestingly, when the Cassini space probe first arrived at Saturn, astronomers thought that
Enceladus.
it was going to be a frozen ball of ice. But then, surprise, surprise, they spotted plumes of icy particles and water vapor erupting from geysers on the moon's surface. It became clear that there was a global ocean between the moon's rocky core and its icy shell. The same researchers previously discovered that Saturn's moon might be home to complex organic molecules too. Before, scientists thought phosphates could be trapped within the rocky cores of
Enceladus.
and similar worlds. That's why the newest works, which hint that phosphates might also be abundant in the ocean, came as a surprise. Researchers examined 305 ice grains from Saturn's E-ring and found out that 9 of them contain phosphates. And these results were clear and unmistakable. And it's very important because some time ago, phosphine, a compound of hydrogen and phosphorus, was believed to exist in the clouds of Venus. But no one has managed to find any evidence to support this theory. On
Enceladus.
there's no controversy, and phosphates do exist there. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick, but it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking mission to access such a deep environment. On the bright side, as we are, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are 2 great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Then we've got Titan, Saturn's largest moon. It's smaller and has lighter gravity than Earth, but it still reminds us of our planet. Like on Earth, nitrogen dominates its atmosphere. Titan is the only other world in our solar system with lakes and rivers. These water bodies are made of hydrocarbons, methane, and ethane. There's also a subsurface ocean of water, but it's located very deep down, and no one has figured out yet if this ocean makes contact with anything under the surface. If it does, it could provide fuel for life after mixing with complex chemistry on the surface. But
Enceladus,
and the other icy moons aren't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, the biggest part of this gas in the atmosphere is produced by living creatures, for example, by cattle digesting food and emitting, gas. However, scientists think that methane was stable in the Martian atmosphere for about 300 years. And then, in 2006, the methane almost entirely vanished from the red planet. And it happened 600 times faster than the researchers' model accounted for. The question? What or who generated the gas, and where did it go? Another Martian mystery is microbes that might be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true. And they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Ooh, that's a long shelf life. This means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the frozen temperature is similar to that of dry ice. In other words, it's deeply frozen. Let it go. And still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium due to its tough nature. Well, I guess time will show. Anyway, if we don't find life outside Earth in our solar system, we could probably look for it on exoplanets, which is what planets outside our star system are called. Some of them look very promising. The closest to Earth exoplanet is Proxima Centauri b. It's a mere 4.2 light-years away from Earth. Recently, astronomers have found out that this world might resemble Earth even more than they previously thought. It's just 17% more massive than our home planet. It orbits a star that is dimmer and less massive than the Sun. Proxima Centauri b is in the middle of the star's habitable zone. This means that the chances of liquid water and life might exist on the planet. It looks like the exoplanet is tidally locked with its parent star. One of its sides faces the star at all times, and the other is always in the darkness. Scientists haven't figured out yet whether the planet has an atmosphere, is traveling too close to its star, and completes one orbit within 11 Earth days. The radiation from the star might be pulling the planet's air away. If this is the case, Proxima Centauri b isn't likely to have liquid water on its surface. Gliese 832c is 16.2 light-years away from Earth. In the cosmic scheme of things, it's a stone's throw away. This exoplanet is 5 times as massive as Earth and travels much closer to its parent star. That's why a year on this planet lasts a mere 36 days. But since this star is a red dwarf, much cooler and dimmer than the Sun, Gliese 832c gets as much light and heat as our planet. At the same time, it's still unclear if it's similar to Earth. The planet probably has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon occurs when a planet absorbs more heat from its host star than it can release back into space. This means that Gliese 832c is more likely to resemble scorching hot Venus rather than the relatively cool Earth. Hey, I'm cool with that.
Something is happening on the red planet! Scientists believed that they knew nearly everything about its atmosphere, but a NASA rover has discovered something unexpected. There's more oxygen on Mars than they thought, and it behaves in weird ways. In the spring and summer, oxygen levels go up even more, and no one knows why. Now, you might think that when there's oxygen in an atmosphere, it's mostly because there's life somewhere around, like trees on Earth that produce oxygen through photosynthesis. But on Mars, it's not that simple. Non-living processes can also create oxygen, so we can't surely say that its presence means there's life on Mars. Mars has long been one of the main candidates when it comes to looking for signs of extraterrestrial life. Back in the 90s, scientists announced they had spotted potential proof there could be life on Mars because of microbes they had found in a meteorite that had arrived from the red planet. It looked like they had found fossils of bacteria. They actually stumbled upon tiny crystals of magnetite in the meteorite, which they believed could only have been produced by living organisms. It was such a mind-boggling discovery. People were excited, but many were also skeptical. It didn't prove there really was life on the red planet. Maybe there was life there a long time ago. The meteorite is thought to have originally formed on Mars billions of years ago, and to have landed on Earth thousands of years ago. Skeptics soon started to pick apart the evidence and eventually found some things that didn't make sense. For example, these magnetite crystals. No one could be sure how they formed. Why do they have to be bacteria? Some research has shown they could be the result of shock waves. Recently, the Perseverance rover has collected a couple of new rock samples from the Jezero crater on Mars. The theory says that about 3 billion years ago, before the red planet lost most of its atmosphere and basically just dried out, there was a big lake with a river flowing from it in that area. Whoa, what a great environment for life! Perseverance studied mud samples it had found on the bottom of the evaporated saltwater lake. Scientists were amazed to see a record number of sulfate molecules, something we usually find in mollusk shells on our home planet. Such organisms evolved a couple of 100 million years ago, but maybe there was a time when some of their space ancestors lived in water bodies on Mars. Mars has weaker gravity than Earth, which means these weird species could have got really big there, way bigger than their Earth cousins. Gravity plays a significant role when it comes to limiting the size of organisms. Bigger organisms need more energy to move against gravitational forces, but the creatures that may have lived there long ago are just a mix of hypothesis and our imagination, something that's still really hard to prove. Meet the Curiosity rover, another robot NASA is using to explore Mars. Curiosity has been in charge of measuring the composition of the atmosphere of the red planet for many years now. The rover has discovered that it mostly consists of carbon dioxide and a little bit of nitrogen and argon. The atmosphere of Mars has only 0.1% of oxygen, since, as far as we know at the moment, Mars doesn't have plants that could produce enough oxygen. But Curiosity has also discovered anomalies no one can really explain. It's found out that there are spikes in oxygen levels in the Gale crater during the Martian spring and summer. Every year, oxygen levels go up and down in unpredictable patterns there. What's even more interesting is that the oxygen spike is similar to a seasonal spike in methane, which is a gas we often associate with life on Earth. No wonder scientists are scratching their heads and wondering if there's a connection between the two gases, and if they both come from the same source on the Martian surface. Is there something big that breathes there? Come on, we'll be happy even with some small space worms in the soil. There's a type of salt called perchlorates in the Martian soil. Some scientists believe perchlorates might be responsible for the strange spikes in oxygen levels. But like with most things we know about space, it's just a theory. Also, scientists think that perchlorates breaking down in the Martian soil release oxygen too slowly to cause and explain the sudden increase in oxygen levels. One of the suspects is hydrogen peroxide, which is like water's unstable cousin. Hydrogen peroxide forms when sunlight breaks up carbon dioxide and water vapor in the Martian atmosphere. It can seep into the soil and stick to particles underground, which means it forms some kind of oxygen storage tank. Some data even show there are pockets of subsurface water in the Martian soil that may be hiding enough dissolved oxygen to actually support life. But even if the hydrogen peroxide could stay in the soil for millions of years, it would still only explain a small part of the increase in the level of oxygen. So you can't blame it for the whole thing. We can also take a look at an old experiment from the 1970s, where scientists found that moistening the Martian soil caused it to release a lot of oxygen. However, they did this experiment at a warmer temperature than the planet's average. And again, it doesn't explain how the oxygen spike keeps happening every year. None of the clues we have seems to fit the case. Mars may not have enough of its own oxygen, but it's possible to make this gas there. NASA conducted a small experiment where they tried and managed to produce oxygen on Mars. MOXIE is a device that can make oxygen on Mars. It managed to produce enough oxygen for an astronaut to breathe for 100 minutes. This awesome device worked in pretty tough conditions, at night or during the day, at extreme temperatures, and during the crazy dust storms the Red Planet is known for. Despite all this, MOXIE still kept up with producing high-purity oxygen. MOXIE is a clever device that can make oxygen on Mars by taking in carbon dioxide from the planet's atmosphere and heating it up to incredibly high temperatures. This allows the device to pull oxygen atoms from the carbon dioxide and produce breathable oxygen gas. If we want to use MOXIE to make enough oxygen for human missions to Mars, we need to make a bigger version of the device. But if we make it bigger, we might have trouble keeping it at the right temperature and making sure it heats up evenly without breaking. The ultimate goal would be to create an oxygen device that could continuously support a human mission for about 400 days. With a bigger version of MOXIE, we'd have enough oxygen to support crew members and even propel a return rocket to our home planet. When you see the dusty red surface of Mars, you can't say it's a place that hides liquid water underneath. Some say it's too cold for water to exist on Mars anyway. But there are stories that there could be a hidden world of liquid water, just like subglacial lakes in Antarctica. And to find out more, we might have to drill down about a mile beneath the surface. Unfortunately, it's not going to happen anytime soon. But in the meantime, scientists have been using a spacecraft called Mars Express to study radar reflections around the southern pole of Mars. The reflections seem to indicate there could be liquid water, and the planet's interior might be keeping it warm. But some claim it might just be rock. We hope there are underground lakes on Mars because it would be a perfect spot to look for life. After all, scientists have found bacteria living in subglacial lakes on Earth. But we don't know for sure how deep they are, or if they're just small veins of water in the ice. Only time and more exploration will tell.
Way out by Saturn, there's an icy moon called Enceladus. And it's literally spitting out ice into space. And that ice contains the stuff life's made of. Oh, and there's a whole ocean hiding under the ice. And who knows what's living in it. Enceladus is only about 300 miles across. It could literally fit inside the state of Colorado. But even though it's super small, it's got liquid water, energy from hydrothermal vents, and a bunch of chemicals that could actually support life. In other words, it's one of the best spots in the solar system where life could exist. Now, rewind about 20 years. NASA's Cassini spacecraft flew by Saturn and noticed something strange. Enceladus was shooting out little jets of icy particles from cracks near its south pole. Later, scientists realized those jets were coming from a giant underground ocean beneath the moon's surface. When they analyzed the frozen grains from those plumes, they found almost all the elements needed for life: carbon, hydrogen, nitrogen, oxygen, and phosphorus. Only sulfur was missing. The only problem was, most of those samples came from Saturn's E ring, a huge ring made of dust and ice that surrounds the planet. And those particles had been sitting out there for decades, maybe centuries, meaning they could have been changed by space radiation. So no one could say for sure if those life ingredients really came from Enceladus itself. But now that's changed. A new study has just confirmed that fresh ice grains, the ones newly blasted out from Enceladus, contain organic molecules, including stuff like nitrogen and oxygen. Here's how scientists figured it out. In 2008, Cassini flew right through one of those icy geysers, and it literally got splattered with tiny particles. They hit the spacecraft's dust detector at insane speed, 11 miles per second. That's fast enough to separate all the molecules, so the team could see what they were really made of. Then the scientists used a technique called mass spectrometry and managed to study those fresh grains in detail. They found molecules that on Earth are part of certain chemical reactions. Those build the complex structures life needs to exist, including ones that may contain nitrogen and oxygen.
One of the researchers said that this likely proved that those complex organic molecules hadn't formed in space. They might have actually been coming straight from Enceladus's ocean. Another scientist explained that those molecules could play an important role in biological processes. All this means that Enceladus might really be habitable. But even if there's no life there, that's still a big deal. Because then we have the right to ask, wait, why isn't there life when all the right conditions are in place? The story doesn't end there. The European Space Agency is already planning a future mission to actually land on Enceladus, right at its south pole. They want to scoop up more samples and see what's really going on under all that ice. The launch is planned for sometime in the early 2040s, so in just a few decades, we might finally find out whether this tiny frozen moon is home to some bizarre life forms. But Enceladus isn't the only potentially habitable place we know about. Admittedly, the others are beyond the edge of our solar system. Like 3 possible super-Earth planets orbiting a nearby orange dwarf star. Now, super-Earth is just what scientists call planets that are bigger than Earth but smaller than the icy giants like Uranus and Neptune. Scientists from the University of Exeter found that those exoplanets were orbiting their parent star, HD 48498, which sits about 55 light-years away from Earth. That's practically our cosmic neighborhood. Each of these planets takes a different amount of time to go around its star. One needs 7 Earth days, another 38 days, and the last one 151 days. And the coolest thing is that the outermost planet might actually be hanging out in the star's habitable zone. That's the sweet spot where it's not too hot and not too cold for liquid water to exist. It means the planet's surface could be comfortable enough for water to exist without boiling or freezing. This makes it a great candidate for life as we know it. Over 10 years, the team collected nearly 190 super precise measurements using cutting-edge equipment that looks at the light coming from stars. By checking whether the star's light is slightly shifting toward us, this is called blue shift, or away from us, that's red shift, they can figure out if a planet is tugging on it. The host star itself is an orange dwarf, something like our Sun's smaller and calmer cousin. It's similar to the Sun in many ways, but as an orange dwarf, it gives off less radiation than our yellow dwarf star does. The coolest part is that this is one of the closest planetary systems we've ever found that hosts a super-Earth in the habitable zone around a Sun-like star. Now, super-Earths aren't exactly rare. Scientists have found over 6,000 exoplanets since the first one orbiting a Sun-like star was confirmed in 1995. To spot such distant worlds, astronomers use all sorts of tools like NASA's Kepler telescope, launched in 2009 to find Earth-like planets in the Milky Way. Let's sneak a peek at some of the most exciting exoplanets out there. Gliese 667 cc is only 22 light-years away, even though that's still about 129 trillion miles from us. It's about 3.8 times the mass of Earth, and zips around its red dwarf star in just 28 days. So a year there is 13 times shorter than ours. Its red dwarf star is cooler, and the planet probably sits in the habitable zone, though occasional stellar flares could give it a sunburn. Kepler 22b is way farther out at 600+ light-years. It was the first Kepler planet found in a habitable zone. It's about 2.4 times bigger than Earth, and we still don't know if it's rocky, liquid, or gaseous. Its orbit is close to Earth's, taking 290 days to circle its G-class star, smaller and colder than our Sun. Kepler 69c is a whopping 2,700 light-years away. This planet is almost 70% larger than Earth. Its orbit takes 242 days, putting it in a Venus-like spot in its system. But since its star is only 80% as luminous as our Sun, the conditions on that planet might be way friendlier than those on Venus. We discovered TOI 733b in 2023. This world is about 245 light-years away. It orbits its star super fast, taking just 4.9 Earth days. But the coolest thing is that it might be completely covered by a massive ocean. Could there be life in that ocean? Time will tell. GJ 1214b is 40 light-years away, pretty close by space terms. The planet is almost 3 times Earth's diameter and 8 times as heavy. It needs 38 hours to orbit its red dwarf star. The surface temperatures there hit 450 degrees Fahrenheit, and with all that heat and pressure, water behaves in crazy ways, like hot ice or superfluid water. By the way, that superfluidity is wild stuff when water moves like magic without friction. But don't try it on Earth. You'll just get dehydrated. Proxima Centauri b is the closest super-Earth, sitting at just 4 light-years away. It has a similar mass to Earth's, but a year there is only 11.2 days. Its star even wobbles a bit thanks to the planet's gravity. That's actually how scientists discovered it. The planet sits in the habitable zone but gets blasted by extreme UV radiation because it's super close to its star. Right now we can't even study its atmosphere. And finally, TOI 715b. This one orbits a red dwarf, which is smaller and cooler than our Sun. These tiny stars are pretty great for finding habitable worlds because planets can orbit close without frying. TOI 715b may have once had a super thick atmosphere like Neptune's, but it might now be losing it. Scientists need more research to see if it's now a watery, rocky world. In any case, some of these planets might have oceans, some might be way too hot, and some could even be our distant cosmic cousins. Either way, each discovery helps us understand the universe a little better. And who knows, maybe someday we'll even set foot on one of those super-Earths.
Hey, look up! There's a meteor shower happening right now! Okay, not really, but I made you look. If you're a fan of full moons, there's one coming up very soon, on February 27th to be exact. I really hope this video comes out in time. The moon will be lit up right in front of our eyes because it will be located on the opposite side of the Earth, where the sun is. It will help illuminate the moon, providing us with a night to remember. Take a good look at it. Doesn't it sort of resemble a huge snowball just hanging from the sky? Some native tribes in the northern hemisphere of our planet might have thought the same. That's why they used to call it the snow moon. You know, when it was big and full, like this. Okay, go ahead and grab a telescope now, because on the 9th and 10th of March, there are 3 planets that will line up for your aesthetical pleasure. Starting from top to bottom, you'll see Jupiter, then Saturn, and last but surely not least, Mercury. Now, depending on how good your telescope is, and if you've even got one, chances are you'll see some details of these 3 planets. You adjust your telescope a bit, and there it is, another planet. Almost like they're not thousands and thousands of miles away from each other. But that's not all. They'll be visible to the unaided eye too. This means you won't even need a telescope. Well, you'll probably see them like this, 3 bright white balls in the sky. Still astonishing though. You'll need to be looking at the southeast around half an hour before the sun rises, and voila, there they are. In the mood for a relaxing shower? How about a meteor shower instead? This time, you can keep your telescope safely stored, and you don't need to worry if you miss one or two of these showers, as there are quite a few happening this year. They're pretty evenly spread out too, and I don't mean the meteors. Those come close together. Grab your calendar and put a reminder on these months. You can choose from April, August, October, November, and December. Some months even have 2 showers instead of only 1, like October and November. Choose the month and day that works for you. Just check your calendar again. If you don't mind it being a bit chilly, just wrap yourself up in a blanket and hop in the back of your pickup truck. Then, all you have to do is stare up and enjoy the sky all night long, waiting for the shower to happen. Or, if you like to work by the clock, set up an alarm to wake you up in the middle of the night. That works too. Mercury's coming right at you! Watch out! Nah, don't fret. It's still right up there, just a bit closer than usual. That's because on the 17th of May, it'll be at its greatest eastern elongation. What this means is it will be easier to observe. Right after sunset, point your eyes to the skies in the west and try to look for the planet. This happens again during the 4th of July, but this time you'll have to look to the east. You might need a compass. Start your celebrations early in the morning, just before the sun rises, with a gorgeous view of Mercury, and of course a cup of coffee in your hand. If you still don't catch it then, try September 14th or October 25th. How about when the moon loses its natural white color? This happens just a few days after Mercury's first performance on May 26th. It's called a total lunar eclipse. The moon will get gradually darker, as if someone was dropping dark red paint on it, until it finally reaches this sort of rusty red color that you can see on the screen. Not all of us will be able to see this unless you're on a cruise in the Pacific Ocean or in the calm fields of Eastern Asia. If you live next to the Tokyo Tower, you're in luck. It'll be visible throughout the whole of Japan. And if you happen to live in the western part of North America, you'll also be able to see the moon shapeshift. Well, not quite shapeshift. It's not going to turn into a wolf or anything. That only happens if you're a werewolf, which I definitely am not. So it's more like a color shift. Still, on the moon, picture a massive black hole. Well, this next astronomical event kind of resembles that. On June 10th, during the annular solar eclipse, the moon will be the furthest it ever gets from Earth. While it's doing this, it ends up covering most of the sun, leaving just a bit of its curvature for us to see. If you happen to look at the sky during this time, what you'll see is a massive ring of light. Chances are you won't be able to tell that's the moon out there, since it'll be the same color as deep space, the absence of color, or just a very deep black. Oh, and that ring you're seeing? That's the sunlight. Okay, since we're talking about rings, I've got one for you, Saturn's ring. This planet is the full package. It's a planet, it has a ring, and get ready for this, it has 82 moons. It feels like every year a few new ones pop up out of nowhere. Anyway, during August 2nd, the planet will be at its closest point to Earth, and the sun will help us catch a good sight of it by brightly illuminating it. Not only will it be brighter than it ever is during the whole year, but it will also be visible all night long. This is the time to get that telescope ready again. A medium-sized one should do the trick. That is, if you want to see its rings and some of its moons, the ones that shine the brightest. Another planet that's coming closer is Jupiter, this time on August 19th. The same thing that happened to Saturn will happen to it. The sun will shine bright on its big planet face. The only difference is that this time, if you have a good pair of binoculars lying around, you'll be able to see the planet's 4 largest moons. Although they'll look like tiny dots, but now you know what they really are. Okay, so you've been thinking about those meteor showers I mentioned earlier. Well, this one is the best there is. It's called the Perseids meteor shower, and it almost looks like the sky is a pitching machine, except it's pitching meteors. During this particular shower, you might even be able to observe up to 60 meteors per hour. They're very bright too. Look at them go! Zoom! Oh, there goes another one. The best days to get cozy, sit on the grass, and just lie there looking at the sky is during August 12th and 13th. Usually, when these 2 days come around, the sky's dark and clear, perfect for a meteor shower. Picture a slightly red moon. That's called the partial lunar eclipse, and it happens during the 19th of November. This same red moon will get darker and darker as it moves through Earth's shadow. It won't be visible to everyone, though. Here's a globe. Let's mark the places where you can see this partial lunar eclipse. First, we got Eastern Eurasia, then Japan. The Pacific Ocean's included in this list too, but unless you got a boat, you're likely not going to be there. Then we've got North America, Mexico, Central America, and lastly, some parts of Western South Africa. Grab a hold of your eclipse glasses and get ready for this last one. It's the last solar eclipse of the year. This one in particular is the best one to catch, as the moon will block the sun for almost 2 minutes. You'll be able to see the almost ghost-like sun's corona, also known as its outer atmosphere. The sad part is, you'll have to be in Antarctica or the South Atlantic. Just be careful out there. I heard it gets a little chilly.
You take a rocket to the moon. It lands. You put on your work uniform and go to work your shift at a local factory that extracts water from beneath the surface of the moon. There's also fuel plants here. Dozens of people and rovers are roaming the expanse of Earth's natural satellite. When your shift ends, you board the rocket again. It takes you back home, just like a regular bus. That's exactly what NASA is planning to do. In the first stage of this project is the Prime 1 mission. Prime stands for Polar Resources Ice Mining Experiment. The mission starts in 2022. Let's follow it step by step. A booster rocket and second stage are assembled on the launch pad. Ignition. The rocket's engines begin to burn fuel, and we go up. Soon, the rocket reaches a speed of about 24,000 miles per hour. At that speed, you could travel the distance from New York to London in just 8 minutes. Once the booster uses up all its fuel, it undocks and makes a soft landing on Earth. The second stage with the payload capsule fires its engines a couple of seconds after the first stage undocks, so the rocket continues moving up. Once it reaches orbit, the payload capsule opens. It releases the lunar lander Nova-C. It's a cylindrical spacecraft, as long as a sedan and slightly wider than the height of the average person. It starts its engine and begins its journey. First, the lander makes a circle around Earth. This is a gravitational maneuver that helps it to gain speed without wasting too much fuel. Because the lunar lander is still in orbit, Earth's gravity affects it. The spacecraft looks as if it's falling, but not to the surface of our planet, along its orbital trajectory. After one lap around Earth, the lander adjusts its trajectory and heads for the moon. The distance it needs to cover is 238,600 miles. That's like 9.5 trips around Earth, or 93 trips across the United States from coast to coast. Modern spacecraft can cover this distance in as little as 9 hours. That's a bit more than a journey from New York to Los Angeles by plane. At the same time, it took the first astronauts about 72 hours to get to the moon. Soon, Nova-C is near its destination. It makes another circle around the moon while it descends. Scientists have already chosen the perfect plane for it to land. There are several requirements. First of all, there should be signs that there might be ice under the surface in this location. Second, the lunar module should be able to maintain radio communication with Earth. And this is impossible if the lander is on the far side of the moon. When the first astronauts flew around Earth's natural satellite, contact with them was lost for a few minutes. The connection only resumed when their spacecraft came out of the lunar shadow. And the last requirement for the landing area is sunlight. The lander has solar panels to power its scientific equipment, onboard computers, and communication modules, so it needs direct sunlight. The lander is getting closer to the surface of the moon. The spacecraft is slowing down as it approaches the landing site. Now, it's almost hovering in midair. A few more seconds, and touchdown! The spacecraft makes a soft landing. It's time to drill through the surface. For this, the lander has a device called the regolith, an ice drill for exploring new terrain. To put it simply, it's a large, 3-foot-long drill. That's almost as long as a grown-up person's leg. Once the right spot is chosen, the device gets lowered into the lunar soil. Drilling will have several stages. Lander will have to lift the drill several times to get the soil out of the drill hole. Otherwise, It may damage the drill bit. Next, the lander will have to analyze the soil composition. To do this, it carries a mass spectrometer, observing lunar operations. Shortly, M-SOLO. Its work is based on a simple principle. It ionizes or charges particles of soil, making them move. Then it creates a strong magnetic field, which affects the charged particles, making them change their trajectory. Different substances, their molecules, and atoms move differently in the magnetic field. So, by analyzing the changes in their trajectories, we can identify the mass and charge of each particle. All we need to do next is look at Mendeleev's periodic table and see which atoms we can find in the samples. Scientists hope to find H2O, water. The south pole of the moon is an ideal place to keep ice within reach of our drill. The equator would be a great place to maintain radio contact and power the solar panels of the lander, but this area is likely to be too hot to have any ice. The lander will also carry a lunar hopper. This thing will be used to explore the surface of the moon. It will carry a load of about 2 pounds. Scientists will also test 4G communication technology. The lander should have some special modules for this. If the test is successful, people might be able to use cellular coverage for communication on the moon, like we do on Earth. But the main goal of the mission is to prove that the resources found on the moon can be used in the future. As early as 2023, NASA plans to send an autonomous rover called Viper, which stands for the Volatiles Investigating Polar Exploration Rover, to the moon. It'll land at the moon's south pole for the same reasons: the connection with Earth and sunlight. The rover itself will be about the size of a golf cart. It'll carry a drill and soil analyzer. Scientists have already laid out a route for the rover. It's about 10 to 15 miles long. It'll take Viper 100 days to travel along that route. It'll drill the soil in search of lunar ice and mark its findings on the map. It will be necessary to prepare for astronauts' arrival to the moon. It'll also help to provide them with valuable resources, like water. Later in the 20s, NASA will launch the Artemis mission. For this purpose, scientists have been constructing the Orion spacecraft for decades. It can carry 6 astronauts. The launch vehicle that will take Orion into orbit is called the Space Launch System. When ready, it'll be the most powerful rocket in human history. The first flight will be uncrewed. It's scheduled for 2022. Like the lunar lander, the spaceship will ascend into orbit, make one revolution around our planet, and go to the moon. Once it reaches the satellite, it'll stay in orbit for 6 days and then return to Earth. It'll spend a total of 25 days in outer space. The second mission is planned for September 2023. This time, we'll send 4 astronauts to the moon. They will fly around Earth's natural satellite and return without landing on the lunar surface. This will be the first crewed mission to the moon since 1972. The third mission, Artemis 3, is scheduled for the 55th anniversary of the first lunar landing in 2024. 4 astronauts will travel to the moon's orbit. Once there, 2 of them will move to the Starship HLS. This is a new lunar lander designed by SpaceX. Then they will make a soft landing on the moon's surface. The astronauts will spend several days there. Then the lander will fly back into orbit, dock with Orion, and return to Earth. There's also plans to build a space station in lunar orbit, the Lunar Orbitable Platform Gateway. It'll be almost like the International Space Station. It'll be assembled from a lot of modules, just like the ISS. There will be a power and propulsion element. This is going to be the first module equipped with engines for maneuvering and propulsion. There will also be solar panels that will power the station. One more module will serve several purposes, including communication and refueling. Then, there will be several living modules. They will be able to host several astronauts for a period of up to 90 days. That's where they will eat, sleep, train, and conduct scientific experiments. The station will be equipped with a robotic arm. It'll help spacecraft dock with the station, as well as install additional scientific equipment outside the station. There will be an airlock module. Incoming spacecraft will be able to dock with the station there. It'll be like a parking lot for dropping off and picking up passengers. Astronauts will be able to use it as a door to outer space. There will be a sample return vehicle, a small spacecraft that will deliver samples of lunar soil to the station. It'll be fully robotic. the Gateway will be much smaller than the ISS. For comparison, the near-Earth station now consists of 11 modules, and its total cost is about $150 billion. In the future, we'll use this station as a launch pad to send spaceships to other planets, like Mars, or into deep space. Rockets launched from the ISS will need much less fuel, because they won't have to fight Earth's gravity. But the astronauts on the Gateway will be in more danger than on the ISS because of radiation. Earth's magnetic field acts as a shield that disperses the sun's harmful rays. And astronauts staying there don't get much more radiation than the passengers of a commercial airplane on Earth. The moon is too far from our planet's magnetic field, so all the modules of the Gateway station will have to be additionally protected from solar radiation.
Very recently, astronomers have found 3 potential super-Earth planets orbiting a somewhat close orange dwarf star. The term super-Earth is used to describe a planet beyond the solar system with a mass higher than that of Earth but below those of the ice giants of the solar system, Uranus and Neptune. An international team of researchers, led by Dr. Shweta Dalal from the University of Exeter, found that the exoplanets were orbiting star HD 48498, which is located around 55 light-years away from Earth. The planets travel around their star in 7, 38, and 151 Earth days, respectively. The study describing these findings appeared in the journal MinRes on the 24th of June 2024. The coolest thing here is that the outermost exoplanet candidate orbits in the habitable zone of its host star, and the conditions there might be comfortable enough for liquid water to exist on the surface without boiling or freezing. Such habitable regions around stars are also known as the Goldilocks zone and are believed to be ideal for potentially supporting life. Another reason this discovery is so important is that the orange host star is like our Sun. But since it's an orange dwarf, it produces less radiation than our yellow dwarf star. It's also the closest planetary system to host a super-Earth in the habitable zone of a Sun-like star, which makes this discovery super exciting. It can help us move forward in our quest to locate habitable planets around solar-type stars. Who knows? Maybe this planet will be our new home one day. These potential super-Earths were detected thanks to the HARPS and Rocky Planet Search Program. Throughout a decade, the team taking part in this research has collected nearly 190 high-precision measurements using special equipment. By analyzing the spectrum of light coming from a star, astronomers can figure out whether it's moving toward us, this is known as blue shift, or away from us, that's what we call red shift. And still, to make sure their findings were correct, the team used lots of different methods and comparative analysis. Everything confirmed their conclusions. There indeed are 3 planetary candidates with minimum masses ranging from 5 to 11 times the mass of our home planet. The team also believes that the proximity of the star, together with the outermost planet's favorable orbit, can make this system a great target for future studies. Hopefully, further research will open doors for our understanding of planetary systems and the potential of life outside our solar system. Scientists have already discovered more than 5,000 exoplanets, which are planets outside the solar system, since the first such world was confirmed orbiting a Sun-like star in 1995. To find those distant planets, astronomers used different equipment, like NASA's Kepler Space Telescope, launched in 2009. Its mission was to find as many Earth-like planets dwelling in the Milky Way galaxy as possible. But it's not the only instrument used for searching exoplanets. Anyway, now let's look at the most exciting and promising of these worlds. Gliese 667 cc is a mere 22 light-years from Earth. But even though it seems close, it's still around 129 trillion miles away from us. The planet itself is around 3.8 times as massive as Earth and completes one orbit around its host star within 28 days. In other words, a year on that Earth-like planet is 13 times shorter than a year on our planet. Luckily, the star is a cool red dwarf, so the exoplanet most likely lies in its habitable zone. But there's still a chance that this world might be regularly baked by the flares coming from its parent star, which is not cool on many different levels. Kepler 22b is way further away than the previous world, more than 600 light-years away from our planet. It was the very first Kepler planet found in the habitable zone of its star. This world is larger than Earth. It's about 2.4 times our planet size. Sadly, we still don't know whether this planet is rocky, liquid, or gaseous. The orbit of Kepler 22b is similar to Earth's. It takes the planet 290 days to orbit its G-class star, which is kind of like our Sun. But this star is smaller and colder than ours. Another Kepler planet, this time it's Kepler 69c. It lies a whopping 2,700 light-years away from us. This world is also almost 70% larger than Earth. Researchers know nothing about its composition, but they found out that the planet needs 240 days to complete one orbit. This makes its position in its system like that of Venus in our solar system. At the same time, this world might be more habitable than Venus since its host star is a bit less luminous, 80% of our Sun. TOI 733b is a recently discovered world. It was found in 2023. It's out there, 245 light-years away from Earth, and needs just 4.9 Earth days to complete an orbit around its star. But the coolest thing about this planet is that it might have a massive ocean. According to scientists, the planet is likely to be completely covered with water. Does that mean there could be life on this super-Earth? Time will tell. GJ 1214b is located 48 light-years from Earth. This planet is a super-Earth, almost 3 times bigger in diameter and 8 times heavier than our home. It orbits around its red dwarf star faster than you can binge-watch your favorite series, finishing a complete loop every 38 hours. But it's not just the planet's size or orbit that's out of this world. It's pretty hot out there, with mind-melting 450 degrees Fahrenheit. But the coolest thing is that this planet is practically drowning in water. The sizzling temperatures and crazy high pressures on JG 1214b create some cool materials like hot ice and superfluid water. Superfluidity is something that happens in liquid helium when it's almost as cold as it can get. On Earth, water totally missed the memo about being superfluid because it needs ridiculously low temperatures and off-the-chart pressures to pull off that trick. Still, there's not much use in superfluid water. Even if you try it, you'll just get dehydrated. The super-Earth that's closest to us was discovered in 2016, and it's called Proxima Centauri b. It's located a mere 4 light-years away from Earth and has a mass remarkably similar to that of our planet. A year on Proxima Centauri b is short. It only takes the planet 11.2 days to complete a circle around its central star. Scientists discovered this world after they noticed that its parent star was slightly wobbling. They hadn't been sure what exactly had been happening there until they realized Proxima Centauri b's gravity probably produced pulls and tugs that caused these wobbles. Although the exoplanet is traveling in the habitable zone of its star, Proxima Centauri, it is exposed to extreme ultraviolet radiation, all because it lies very close to its parent star. Also, none of the telescopes that are currently working and exploring exoplanets are positioned well enough to capture the light from the atmosphere of this super-Earth. Most things there are still a mystery to us, even though we're talking about a planet that's really close. Super-Earth TOI 715b orbits a red dwarf, a star smaller and cooler than our Sun. At the moment, such stars remain prime candidates for finding habitable planets orbiting them. Those miniature rocky worlds have far closer orbits than those circling around stars like our Sun. But since red dwarfs are small and cool, the planets don't risk anything when crowding closer. They're still safely within a star's habitable zone. Experts say that TOI 715b might have once had an atmosphere thicker than that of Neptune, and now the planet could be in a transition state where it's losing its atmosphere. To confirm this suspicion, scientists need to do more research, and they might finally learn whether this planet is a watery terrestrial planet.